Hey YouTube, welcome back. Today we have this problem. It's called complement of base of 10 integer. The complement of an integer is the integer you get when you flip all zeros to ones and all the ones to zeros in its binary representation. In a binary representation, like each number or each character is only represented by 1 and 0. So for example, 5 is represented by 101 and 2 represented by 010. So when we flip 5, we get 2 because 5 is 101, and when we flip all the 1 to 0 and all the 0 to 1, so we'll get 010. And when we have an integer in, and we should return the numbers that equivalent to it. So what should we do? So let's start into the solution is quite straightforward, but what takes time is to just understand how we will do this solution. So let's assume that we have 1 0 0 1 1 0. For example, let's say that we have this one, or at another one, and let's say that let's say that we wanna flip the this number. So we will the solution is that we will go bit by bit and try to from right, for example, and just try to go with bit by bit. Like this will be 0, this will be 1, this will be 0, this will be 0, 1 1 and 1. I just like that. So in order to do this solution, we should just think about that we could initiate maybe like a 1-bit variable, which we could use to flip each bit. We could initiate a marker variable. Maybe we could we call it to do something like that, and this one we'll use it to stop the loop, because we will make a loop and we loop through each bit. And after that we could like flip the current bit. So if we finish this one, we flip the current bit, so we go with the next one. So I guess the algorithm, let's say that we have num. If we want to flip the current bit, it will be num sorry, it will be num a bit like that, and we prepare for the next run, and shift flip variable to the left and to the variable to the right, and after that we could return num. So let's see how we will do that. First of all, we start with if n equals 0, we return 1, just the base case. And after that we have let to do equals n let bit equals 1, and I will say a minute, and I'll say let do equals and let bit equals 1, and yeah, I guess that's all the variables that we need. I would say while to do doesn't equal 0, I will say n equals, because we are now flipping it, and let's flip this one. Where's the character that we used to flip? Okay, 1. So right now no, we flip by bit. So right now we flip from right, and we will prepare for the next run. Right now we flipped. Right now let's prepare for the next run. So I will say like bit will equals bit 1 and to do will equals to do. So we shift this to the right and shift the other to the left. And 1, and after that we return. And so let's just talk about what that means, because a lot of people maybe like they don't get what's happening. So this one in this line, we performs a bitwise XOR operation between in and bit, effectively flipping the value of the current bit in n. Okay, and this approach toggles bits from 0 to 1. Okay, so right now here we're flipping the next lines. This one we are shift the bits of bit 1 position to the left. Okay, effectively multiplying bit by 2. This prepares bit for the next run. Okay, to toggle the next bit in n. And we have right now this one is that we shift the bits of to do 1 position to the right, effectively dividing to do by 2. This keeps track of the remaining bits in to do that we need to toggle, and these what each line we put for. And these operations are performed in a loop that we have here to iterate through all bits in n and toggle them by the end of the loop. N will have its bits complemented, giving the bitwise complement of the original number, and yeah, that's it basically. So that's my solution for today's video. I hope that my solution was quite good. If you find my solution is good, make sure to subscribe, hit the notification bell so you will never miss a video, and see you in future problems.